Welcome everyone to 2.6 Notes. We are learning about function notation today. One thing you'll notice that the first three letters of function, F-U-N, and that's what we're going to have a lot of right now. So what is a function? Well, the first form we got to recognize is the notation. So we have y equals f parentheses x. What does that mean? Well, this is simply another name for y. Okay, and how do we say it? We say f of x. So this literally means f of x. That's how we would say that. Okay, it's another name for y. These two are equivalent to each other. F of x and y are the same thing. Now, it's just when we're talking about functions, we know that each x input will only have one y output. Quick shout out to one of my former students who made this moose drawing. Absolutely fantastic. Great artist. Really appreciative of it. So we're going to go ahead and jump into some examples to see how it works. We're talking about functions and f of x. Find the value of each function f for each value of x. I added a couple extra words in there, but you guys get what I mean. So first thing we do is x equals 2, aka f of 2. This is our kind of parent function. Okay, so this is what we're going to be plugging stuff into. That turned out really ugly. Let me try that again. Like that. Okay, so we have f of x equals 3x minus 5. If you want, you could write it as y equals 3x minus 5, or you could write your output equals 3x minus 5, where x is your input. So this would be your, let me change this to like an orange color. That would be your input. Okay, so again, we're inputting something and we're expecting only one output for functions. So f of 2. So what do we do here? We can write this as f of x equals 3 times, and we're inputting 2. That's what it's asking. Now, this is telling us what we have to input. Okay. Initially, it's written as f of x, so that's why you see an x here, because those always need to match. So if it says 2 here, we need to also put a 2 over there, and then we just simplify. Now, a common mistake I see is we have students write this, and then they get super confused, or they write it like this. They write 3x like this, and then they get confused, and they think they have to solve for x. That's not what it is. Essentially, what we're trying to do is we are trying to find the value of f of 2, so we just leave it alone. We just leave him by himself, okay, and we're trying to find what this equals at the end, and we're simplifying that. So we're finding the value left in the box. So we get 3 times 2 is 6, and then we get minus 5. We get f of 2 equals 1, and that's our answer. Let me change the color here. Make it like a answer color green. So we have f of 2 equals 1. That's what it's asking. Find the value of the function. There should be the function f for each value. Okay, and that's what the value is at 2. So now we have a different one. We have x equals negative 1. Again, we're inputting it into the same function. Let's change the color this time. Let's go light blue. 3 times negative 1. That's our input. These need to match. Instead of writing x and x, we're going to write negative 1 and negative 1 minus 5. And our goal here is we're just trying to find the value of negative 1 for this function. So we get 3 times negative 1 gives us negative 3 minus 5. They're both negatives. They're going to become more negative, and negative 8 is the value of f of negative 1. So pretty simple here. Essentially, this is just substitution. Another way to think of it is substitution. Okay, and then we have f of negative 3. Let's choose a different color. Let's go this magenta. Equals 3 times our negative 3 minus 5. Negative 9 minus 5, sorry. And then we get negative 14 is equal to f of negative 3. So pretty simple there. And we'll move on. Example 2, same thing. Just because the function changes to something that's not linear doesn't mean that it changes the process. So we have f of x here, and you'll notice that the x matches. Thought I was going to sneeze, but I held it back. All right, so we have x, and you'll notice that we have an x written everywhere here. Okay, if this said f of g, there should be g's everywhere. Okay, so the x needs, if there's an x written here, there needs to be x's here. Now, if there's a 4 written there instead, inside the parentheses, we're going to change this so that there's 4's written here. So we're at minus, and now we're going to write parentheses 4 squared plus 5 parentheses 4 minus 3. Very important distinction here. This causes a lot of simple mistakes. People get this question wrong all the time. This means right here we are going to apply the negative second. Okay, so this negative applies after. Negative applied second. After we square it. Okay, that's why I put it on the outside here. We're inputting 4 into parentheses. The first thing we're going to have to do is squared, and then we put the minus out in front. If it was like this, negative x squared, then that's different. Then we're going to put in negative 4 square, and it's going to end up being positive 16, but that's not the case here. It needs to be in parentheses for it to be like that. So let me cross that out. Okay, and let's continue with our magenta. So we have, now we just need to follow order operations and simplify. So we have 4 squared equals 16. The minus comes out in front. Then we have plus 20 and then minus 3. So we're going to have negative 16, and this is going to be negative 19, and then plus 20 is going to give us a positive 1. So f of 4 equals a positive 1. I should have changed color. Sorry if you are looking for some variety. I messed that up. Example 3. Okay. Let's change color. Let's go, I guess we can go this pink color. So here we have an x, so we should have an x written there, and we do. Now, since we have a plus 1, we have to replace x. We're substituting x with a plus 1. So we write 2 parentheses, and then we write a plus 1. And then plus 3. So we're writing the same thing. The only difference is these two values need to be the same. Let me change the color here. Style. Let's make it like this dark blue color. Okay, so those need to match. They always need to match here. Okay, let me change this to green just so it stands out a little bit more. You can always pause the screen and follow along, but yeah, this is basically the overriding principle, the x and x in the top, but if we change it to a plus 1, we replace the x with a plus 1. Love that acorn, or that's a pine cone actually. So we have 2 times, we're going to distribute here to solve because we're going to simplify. Okay, so we have 2a plus 2, and then we have plus 3. Oops, it's pink, not the magenta, plus 3. So we get 2a plus 5, and that's our answer. There's nothing left to simplify. That's simply the value when we replace the, let me change the color here. When we replace the x with a plus 1. Okay, now functions can be expressed in multiple ways as we learned in section 2.5. They can be represented with graphs, data table, points, and equations. So we're going to do each one. So we can solve it for multiple cases here. So f of 3, what we're going to do for part A is this is more of the same what we've been doing. F of 3 equals, we're going to replace the x with 3. These need to match as we demonstrated earlier. And then we write minus 7. So that's going to be 9 minus 7, and that equals 2. Okay. This is a different function. This could be a different f of x, or maybe this is f of a, or whatever it is. But this is the different function now when we find out what f of 3 is. So we're going to write in 3, because when we're plugging in values here, remember this is replacing x. So we're going to plug in for x here, and we're looking for 3. This one doesn't have an equation, so what do? Well, we need to look at the pattern here. So we're looking at the pattern, and we know it goes from negative 12 to some unknown value, and that from unknown value to 0, and then from 0 to 6. So we see when we went plus 3 with x, we went plus 6 with y. We went plus 3 with x. It needs to say the same if it's a function. This should say if this is a linear function, where you have to assume it's a linear function. So we need to add 6 here. That will take us to negative 12, and we'll see if this, in fact, gives us the correct result, because we should add plus 6 again, and it should take it to 0, and it does. Okay, so the answer here is the output that we get would be negative 6. So that would be our value of the function at 3. The function f of 3 would equal negative 6. For part C, something similar here. We're trying to see how the x changes each time. So the x goes plus 3 here. It has an unknown amount, and then it has an unknown amount. But we see that it goes from 0 to 6 in 2 moves. So it has to be plus 3, making this x 3. And again, we are asked to find f of 3, so that makes sense that this is 3. So now we have to see what happens with the y's. The y's go from 5 to 3, that's minus 2. Something happens again, it needs to stay the same, and then something happens. It has to stay consistent if it's linear, and we're assuming it is. So this is going to be 1, and then minus 2 should take us to -1, and it does. So our value at f of 3 is 1. Our last function here, this is going to be a great one because it will lead right into a Khan Academy, which I've already made at the time of this video's release, called evaluating, I think it's called Khan Academy Evaluate Functions of Graphs. So we can do the same thing here. Now what do? Well, we're going to look, if we're plugging in a value for x, okay, f of 3, f of x, okay, we're going to look at our x-axis, and we're going to go and find 3 on the x-axis. That's right here, okay? Then what we're going to do is we're going to find our value, as we stated in the beginning. We're going to see what f of 3 equals, the value of the function at x equals 3. So we're basically going to look for our output, y. We're going to look for our output. So we're going to go up, 1, 2, 3, it goes up 3, 4, 5. So here is our point of intersection. This is the point 3, comma 5, and so 5 is our output, and that is our answer. So f of 3 equals 5, final answer. So we saw functions applied in many different ways. Hope you found this helpful. Thank you so much for watching, and I will see you next time on West Explains Best.